3, 2, 1. Hello, everyone. We are excited to share our machine learning project with you today, from customer profiling to loan rate and loan amount prediction. I'm Oliver. I'm here with Dhruva and Deepa. Let's dive right in with a high-level overview. Our main goal for this project was to really automate and optimize how loan decisions are made. We did this by analyzing the rich data set of borrower information from the Lending Club dataset we found on Kaggle. This dataset gave us a really deep look into borrowers, covering everything from their demographics and their financial indicators to their credit histories and like specific loan details. Our entire machine learning approach was built on three-stage pipeline designed around these three key objectives that will be going into much details here today, which is borrower segmentation, interest rate prediction, and loan amount estimation. For a brief overview of our dataset, let's take a quick look at our dataset. As you can see on the screen here, it's quite extensive with over 396,000 loans and 26 different features. Some of our key features we focus on include the loan amount, the interest rate, the purpose of the loan, and etc. And to give you a concrete example of how the dataset looks, imagine a typical borrower profile from our data. They might have about $10,000 as a loan amount for a term of 36 months with an interest rate of 11.44%, and the grade of the loan might be B or B4 for the subgrade. They've been working in marketing for about 10 plus years, and they don't own but rent. That means they don't have a mortgage. You'll see why that's important later. With an annual income of about $117,000. Next, we are going to look at borrower segmentation. Here, our goal was to identify, was to pinpoint meaningful clusters of our borrowers. We did this so we could better inform credit policies and tailor our marketing efforts. We'll walk you through how we did this, covering our pre-processing steps and EDA analysis. For our pre-processing, this was a very crucial part for our clustering. It involved several phases, as you can see on the screen here. We did a lot of feature engineering and carefully handle missing values. Then we addressed outlier treatment, apply log transformation where needed to normalize the distributions of our data set. We also use one-hot encoding for our categorical variables to make them machine readable. And finally, a very important step for clustering, we did feature scaling. For EDA, our exploratory data analysis gave us some really insightful findings that guided our feature selection. With annual income, even after log transformation, as we can see here, we saw a persistent right skew. This tells us that there are few high earners in our data set. For depth of income, most of the borrowers were below 50%, which is good. But we noticed a very high spike near 100%, which could be a signal for potential distress. Credit history is shows a roughly normal distribution, but with a longer tail indicating some borrowers have like very established credit history. Revolving utilization was interesting. It is by model. One group had low utilization while another was approaching 100% utilization. And if we look at mortgage accounts, over half of our borrowers did not have a mortgage. They were renting. And there was a smaller segment that have multiple mortgages. This could be people with higher income that have, more than one houses or living places. Next, we're going to look at how we select our number of clusters. Once our pre-processing and EDA were complete, our next step was to determine the optimal number of clusters for K before running K-means on our skill data. To do this, we used two well-known techniques: the elbow method, which looks at the inertia versus K, and the silhouette analysis, which help us to understand how well separated our clusters are. After selecting K, we then ran K-means and assign a cluster label to each borrower. To ensure this process was efficient, we subsampled 20,000 rows. This allows us to effectively use the elbow method to find where where the gains in inertia started to diminish, and to calculate the silhouette scores to confirm our clusters are well separated. Now, if we look at this plot you see on the screen here, the silhouette plot actually recommended a K of 3, indicating the highest separation among clusters. On the other hand, the elbow plot, the elbow method suggested K could be 4 or even 5, with the point of diminishing returns or inertia clearly visible at K equals 4. Considering both of these measures, we made a strategic decision. While the silhouette score drops sharply after K equal 4, as you can see right here, the elbow curve undeniably flattens around K equal 4. So we decided to choose K equal 4 as our final clusters, as our final cluster. Now let's look at what defines each of these 4 clusters. We did observe an imbalance in cluster sizes. They were not perfectly even. In cluster 1, it's almost like 5 times larger than cluster 0. What they tell us is that like the average borrower profile tends to dominate our data set, while those were like more niche or like outlier segments like cluster 0 were relatively smaller. And this has some like important implications for business decision. So like if a business is thinking about marketing campaigns or changes to credit policy, targeting cluster 1 will hit the largest group of borrowers. And that will give you like a biggest overall impact for the business. However, smaller cluster like 3 or cluster like 0 might actually be high risk or high reward segment. They are smaller in number, but the behavior might be different. Like you think about default rates, for instance, could disproportionately affect the overall business performance. Next, we assign cluster label to be able to aid in the interest rate aspect of our analysis. For the business implications to clustering, we saw for cluster 0, our new borrowers, we see a clear need for introductory products or more guidance. For cluster 1, which is a large group with the large low income group, they will greatly benefit from like credit education and focused retention efforts. For cluster 2, our low risk, high income individual, premium products and loyalty rewards will be highly effective. And with cluster 3, who have like a higher utilization, we need to closely monitor potential defaults and active offer refinancing options. And lastly, for recommendations, we recommend that the business should launch credit building workshop, especially targeting cluster 1. It will be beneficial to develop premium loan offers for those in cluster 2. And for cluster 3, implement early warning labels. This could help manage potential risks more effectively. And crucially, we recommend integrating these new cluster labels directly into like risk models, which will significantly improve their accuracy. And we believe there's an opportunity to continuously refine these segments by incorporating even more behavioral insights. Thank you. And next, we'll move on to interest rate prediction, which will be taken care of by Truva. Truva, you can now take over.
Coming to interest rate prediction. So once the goal was to identify most informative features for this predictive analysis, and we had to find the best model that we use to predict the interest rate. And in our topics, we covered clustering using DB-scan and K-means to give informative features, and we have used five different regression models for prediction analysis, and then we compare the performance of these models before and after clustering, and then we use feature importance analysis for the best model that we have selected among the five models that we have used. Coming to this part, in this chart, we observe the top predictive features based on linear regression coefficients. The strongest positive predictors are grades D, E, and C. Being in grade D increases the predicted interest rate by 3.42, and grade E adds 3.20. On the other hand, loan amount has a negative coefficient of minus 2.6, indicating that higher loan amounts are associated with slightly lower interest rates. And coming to the next slide, yeah, this is basically we have used clustering by using k-means and db scans. These are the outputs that we have got from that. Coming to the k-means clustering results, we have applied k is equal to 4 using a PCA for dimensionality reduction. So this formed well separated borrower groups, which can be later used for enriched sites. And so basically, we can see that cluster one represents high risk borrowers. That means high interest, high DTI, and long term loans. While cluster three includes low risk, high income borrowers with low interest rates and short loan terms. Coming to DBScan results, DBScan was just used, tested for anomaly detection and clustering without needing K. So basically, it identified cluster minus one, which was with extremely high income and low DTI. For the cluster zero, it had a average of 17.16 interest and a 100% term. And coming to the cluster one, it had 12.60 interest and shorter terms. Okay, so basically, this method was used for identifying edge cases that were missed by k-means clustering. Coming to the next slide. So we have used five different regression models, that is linear regression, logistic regression, which is bent, random forest, and logistic regression, which is tuned, and random forest that is also tuned. So we can see the plots that linear regression shows a strong diagonal trend that matches predicted to the actual results, while the random forest models were slightly more flexible but produced higher variance in predictions. So coming to logistic regressions, it kind of struggled with continuous outputs due to binning, so it led to flat segments in the predictions. And coming to next slide. Uh, yeah, this is the comparison between the MAE and R2 score. That is the performance matrices that we'll be comparing for the best model. So we evaluated each model using these two matrices. We found out that linear regression ranks first in both MAE and R2, making it not only accurate but also interpretable and easy to deploy. And coming to next slide. Yeah, this is the one. We can see that both MAE and R2 scores tells that linear regression is the best model because it has a lower MAE value and a higher R2 score value. Coming to the next slide. So this is the results that we found from the linear regression model. The scatter plot confirms the excellent performance of the linear regression model. Predictions closely align with the actual interest rates, especially with along the red 45-degree reference line. While there are some outliers, the overall fit is strong across all interest ranges. Coming to the next slide. So basically, these are the final feature importance that we have selected from linear regression model. When we plotted absolute values of coefficients, grade D again tops the list, followed by grade E and C. Features like DTI, loan status, and credit age had very minimal influence, but could be candidate for exclusion in future model iterations. And coming to the next slide. Yeah, these are the recommendations that we'll be planning on implementing in this part of the analysis. So basically, the first thing is cluster specific modeling. We can use the k-means clustering to each separate clusters. I mean the regression model for each clusters, which can help us capture group specific patterns and also improve predictive accuracy within each segment. And coming to the other part, we can also use advanced feature engineering like interactive terms between two of the features and polynomial features to capture nonlinear relations. And there's also cohort analysis. So basically, if time-stamped data was available, analyzing interest rate trends across time would be easy for us, and it would lead for a better behavior across everything. Coming to next slide. Yeah, I'll pass on to Deepa. She'll be talking about this.
Sure. So till now, we through our machine learning, we did borrower profiling, risk profiling. We did prediction of interest rate. So this piece is about prediction of loan amount. Um, okay, so I'll just go to the next slide. So the goal is, first of all, to identify most informative features, and then uh, use different models to then predict the loan amount. So we will cover different topics like k-means clustering to find out a good cluster that could be used for the by the model for loan prediction. See which model does a good MAE and R2 scores. Then choose the best model to do the loan amount prediction, and then and then using the last the right predictor model, we can then use that to find out the top informative features in our data set. Going to the next slide. Okay, second. Yeah. So we used feature selection through F regression, and using that, we found out on the right hand side, you will see that we found out the best top three for prediction of loan amount, and that was installment, term 60, and interest rate. We then these three were then fed into linear regression model, and the linear regression model also then gave these top three most informative features. Then using these top informative the top three attributes, we then did claim k-means, and the k-means also came up with the top three as installment, term 60, interest rate, but it came up with a cluster 2, which it said was closely aligned. It could help in a better prediction by the models. So after that, we use five of these regression models to predict and see what are the MAE and the R2 scores. So if you see, these are the models that I used was linear regression, lasso regression with alpha 1, ridge regression with alpha 1, lasso regression tuned, and ridge regression tuned. They are mostly the same if you look at the graph, but if you look at the lower left hand side, the lasso regression tuned had a good MAE 597, but the R2 scores were not good. So then I moved on to better other regression models, which maybe could give a better MAE and R2 score. So the next ones that I used was SGD regressor with L1, L2 regularization, SGD with elastic net, and random forest regressor. And here, if you see, the best one looked like it was random forest regressor. And if you look at the MAE score, it was really low, which was 51, and the R2 score was really high, which is the best combination of all. So all of these were plotted. And if you can see, MAE for random forest was the best, and R2 for random forest was the best. So that was then used for the final prediction of loan amount. And this is the plot. So the random forest was then used on the test data set, and this is the final plot that was created. It is, if you can see, the loan amounts that were predicted are tightly aligned to the red line, which is around, which says that it's a good plot and a good model to predict loan amount. And random forest regressor chose installment, term 60, and interest rate as the best and as the top 90% of the attributes in our data set. So that's about uh, the modeling. The recommendations is use linear model when data set is simple, interpretable, and speed matters. Use non-linear model like random forest for complex patterns. Use k-means to create additional clusters, which could actually help with final prediction. Instead of using all features, reduce the data set for the best model behavior. And loan prediction is better with non-linear regression model than linear regression model. That's the end of the last part. But the overall recommendation from for the project is, Oliver, you want to talk about this?
Yeah, so one thing we recommend is a segment driven to implement segment-driven modeling, and that means like we embed clusters to boost downstream model performance. Um, so you know, one thing that what I mean is like we use customer groups to help make our models work better. So we implement clustering and we implement that into like our other modeling we do for our data set.
Okay, and as covered, for complex data patterns, random forest regression model consistently outperforms other regressors. Dhruv, do you want to talk about this?
Yeah. So through clustering, we have identified clear borrower segments that translate into real business values. For example, high-risk groups with long-term loans and high DTI can be targeted with stricter approval criteria or higher interest rates.
All
Okay,
right.
yeah,
Yeah.
go ahead.
Thank you very
Thank you.
much
Thank you,
and
guys.
Thank you.
goodbye.
Bye.